Hey, this is Dr. B, and here we go. This is my fourth stream, and starting to get the hang of this just a little bit here. Um, what we're going to do today is we're going to talk about valence electrons, and we're going to talk about that in the context of the type of exam questions that you're going to see around the topic of valence electrons. It comes up on every exam, every class of chemistry is something you're going to see on tests and quizzes. So, stick around at the end of the stream. I'll drop my chemistry guide for valence electrons in with some practice problems and lots of good information and video links there. So let's just get started. Go over here to my screen. Yeah, there we go. And I can see we have a few more people tonight than we have in the past. I don't know if that means that we're growing or not, but we'll give it a try and see what happens. Here is sodium and chlorine from the periodic table. So when we're talking about valence electrons, that's the electrons in the highest energy level. So they're only the ones on the outside, like for sodium right here, that's a valence electron. There's only one for sodium. That's why it's in group 1. For chlorine, we have 2, 4, 6, 7, and it's in group 17. So it has 7 valence electrons in that outer shell. These are the ones that react. They're the ones when these two atoms come together, they're going to bump into each other first. That's why we get a chemical reaction. So here's a problem you likely see for this type of question on valence electrons. Kind of a general chemistry question. Take a look at that real quick for a second. I'm going to take a look at the chat here and see what's going on. There we go. All right, I see Kubra is here tonight. Excellent. All right, so this is the question we're looking at. And this is a bit of information. We talked about it last night. As a chemistry student, you really need to know the information in this blue box. Just memorize it so you can quickly get that up in your brain. So the element X has atomic number of 6. Atomic number, that's the number of protons. And we can find it right here on the periodic table. Atomic number 6, that's always going to be carbon. So they want to know the number of valence electrons. Hey, Riva. Number of valence electrons is really easy to remember. So these are the group numbers. Remember, groups go up and down. So we have our groups here. In group 1, we have 1 valence electron. Group 2, we have 2. Skip the transition metals. They're a little bit complicated there, so we don't really worry about them in general chemistry. Group 13 used to be called group 3A. It has 3 valence electrons. And 14, that has 4, and there's carbon. So we know that element 6 has 4 valence electrons. So that's really useful. The group number tells you the number of valence electrons. Group 15 has 5, 16 has 6, 17 has 7. Group 18 has 8. All of these, the exception is helium though, because helium only has 2 valence electrons. It only has 2 electrons, so it can't have an octet. It can't have 8. All right, they want to know one chemical property. It's a little bit challenging. How do valence electrons cause something to have a certain chemical property? Well, remember, they're the ones on the outside. They form the chemical bonds. And if you have 8, that's really stable, and you'll just won't react. If you have 7, you're almost to 8. You'll probably get one more. And you have 1, you'll give it away usually. So carbon's right in the middle. So carbon tends to share. It doesn't transfer, it shares. And that gives us a covalent bond. So that's how I would answer that question, that carbon forms covalent bonds because it can't really get 4 more or give it away, so it'll share. All right. So if you had to think about valence electrons, if your teacher or a test, they ask you, what's a valence electron? What would you say? They're the electrons on the outside. They form the chemical bonds. So that's why they're so important. And if you remember the trend here, you're in great shape. Let's try a little bit of a maybe more advanced problem here. Has anyone been asked about valence electrons in chemistry so far this semester here? Because I feel like as a teacher, as a chemistry teacher, it's one of the first things I really start thinking about with my students. All right. Question 2. This is kind of an IB chemistry, International Baccalaureate chemistry problem, maybe an AP Chem. So oxygen is in group 16. Atomic number 8. They want to know the number of valence electrons in an oxygen atom. See if you can figure that out. Put it in the chat. See if you're getting this. Emily's telling me all the time, and I agree with that. It's so integral to learning chemistry. So group 16, atomic number 8. Number of valence electrons. Kubar got it 6, right? So it used to be called 6A because of the 6 electrons. And oxygen, sulfur, they have 6 valence electrons. And it's the same question again, kind of as the first one. How does that help us predict chemical behavior? So if oxygen has 6, to be stable, it needs 8. So it needs 2 more. So when oxygen bonds, so when oxygen forms chemical bonds, it'll bond to get 8 valence electrons. So typically, if it takes something like, say you have magnesium here, that has 2, oxygen has 6 here, the 2 from magnesium will go to oxygen, so oxygen has 2 extra valence electrons. Magnesium becomes positive. So that's why the formula is MgO, magnesium oxide, because the charges are balanced. So I would say we can predict the chemical behavior because they're all trying to achieve an octet. So they'll bond to get octets. Okay. I like that question. So if you looked at oxygen, if you looked at the oxygen atom here, let's move that, make this big. You can see that in that first energy level, we have 2. That's our 1s2. And in the second, we have 1, 2, 3, 4, 5, 6. And those 6 are the valence electrons. These 2 would be 2s2, and all of these together here would give us 2p6, or 2p1, 2, 3, 4, 2p4. We'll go back to that in another problem with those configurations. All right. Actually, let's write the electron configuration for oxygen. You guys know how to do this? Here's oxygen right here. Let me get rid of that. So we look at the first group right here. This is the first energy level. We have 1s1, 1s2. That's full, so we have to come down to 2s. 2s, 1, 2, and then 2p, 1, 2, 3, 4. That's oxygen. Atomic number 8. This is the configuration. This is the highest energy level. So, yep, Guru, you're right. And so if we added 2 more in here, that would move us over here. We'd be stable. So this highest energy level, yep, Emily, you got it too. This highest energy level here is, these are the valence electrons. So you would look at the highest number, 2, count them up. That gives you the valence electrons. It's another way to do it. All right. So I think right now I'm going to drop the PDF that I mentioned earlier into chat because I'm pretty sure I'm going to forget to do it. And I've been creating these guides with my students for a long time, and I've kind of updated them to include my YouTube videos. So I'm going to put it right there in chat for you. There it is. And so you can download that, and it's free. There's no paywalls or signups or anything. Okay. How about we do an AP Chem question? We'll do this and maybe one more. Call it good for this evening. There's my screen right there. AP chemistry questions, they like to ask like one, it says like question number 3, and then it'll have 8 parts to it. So, but this is pretty easy because you guys can, you know how to do the valence electrons pretty readily. Define valence electrons. That's just electrons in the outer shell. They're the ones that bond. They ask how it's related to its position. Here, I might say that all of these here are end in S1. All of these end in S2. Like that diagram we looked at before. If you know your blocks, they all end in P1 through P6. Let me go back over there. So if you memorize this here, that everything here ends in S1, everything ends in S2, everything here ends in 2P1. This is really helpful. This helps you really solve a lot of problems in chemistry. All right. So we have Cl and K, number of valence electrons for chlorine. How many does chlorine have? 7, right? And then potassium right over here, group 1, it has 1. Oops, that's where I want to put those. Yeah, so that's the first part, I. Then we could write the electron configurations for potassium and chlorine. I want to look at this here to do that. So we said chlorine is, now I can't remember where it's at. Chlorine's right here, so it's 1, 2. It's in the 3rd period. Potassium's in the 4th period. So this would be chlorine, and then potassium would be in the 4th. 1, 2, 3, 4. So for chlorine, we said atomic number is 17. Can you guys see there? Yeah. Chlorine would be atomic number 17, so 1s2, 2s2, 2p6, 3s2, move over, 3p6. We've used, actually it would, we have, that's 20, 10, so we actually need to have a 5 here, so they all add up to 17. So that's our chlorine, and chlorine has 7 valence electrons. So if it gets 1 more, it's stable. Potassium, that's 19. So 1s2, 2s2, same thing as chlorine. And then we have 2s2, 2p6. Sorry about that. I had some dentistry work done today, and I feel like I'm fading out a little bit on you. 3p6, 4s1. Is that right? 8? So 10 plus 8 is, yeah. So those are the electron configurations, and you can see if we move the 1 up here, this would have a full outer shell, and then underneath here, we would have a full outer shell for that one. All right. I think the last thing I want to do with this here, because I think I'm probably going to finish up here this evening. I don't feel like I'm doing a very good job. I had some work done at the dentist today, and just my head's not in the right place. I do want to show you about ions, because that's real important. So potassium here, let's copy that and give ourselves some room. This is potassium right here. So it's going to lose this electron. And when it loses that electron, now it has 1 less electron. It becomes a positive ion. And this shell right here, it appears to have 8. So this is full. So we have potassium, which is the neutral element, and then the ion, and it becomes an ion to get this shell full. Copper is actually kind of a more complicated one. It's one of the exceptions. It's one of the exceptions, Emily, you'll see on a lot of tests like AP, tests, probably the NEET test in India. I will get a video I made on that and put it in the chat when we're done here so you can see how that switch happens. Make sure you know what's going on with that. It's a good one to learn that, and chromium. Chromium's another one all the time they're putting on that AP test and so on. All right, I think I'm gonna call it good for the evening here. Like I said, I actually had 2 crowns put on the teeth and the back today, and it really hurt. So I think my brain was affected. I'm gonna stream. I'll be back Sunday evening to do some streaming. If you guys have any suggestions on what's really useful for you, please do let me know. You can find my email address on my website, and that is breslin.org. You can email me if you have any suggestions on how I might improve. Like I said the other night, it's kind of like, you know, when you're learning chemistry, it's really hard at first, but then you get kind of good at it. I'm still learning how to do this streaming stuff. So yeah, your help would be appreciated. Excellent. I'm going to sign off, and I'll stick around in the chat for just a little bit here. All right. Thank you, Kerber. And yeah, Emily, AP style wording it's really interesting. They have a very specific way of writing it. So when you practice those questions, that's probably the best way to study for AP Chem, is to get a book of problems or a set of problems and with solutions and just work through problem after problem. That's a lot of the successful students do that. All right. I'm going to leave this diagram up here in case you haven't. I'm going to copy it. And this diagram is wonderful. Students that have this in their brain, they just do so much better because they can instantly figure out electron configurations. For instance, if I told you, I think calcium is right here, you would know that it ends in 5s1, 5s2. You know that the last part of the configuration is 5s2. So very useful. All right, everybody. Good evening, and thanks for being with me this evening.